My name is Catherine, and this is my partner, Andong. And then the title of our project is Towards a More Interactive Virtual Coach on Rehab Exercises. So the problem that we identified and we tried to solve is for rehab, clinical tests require direct visual observations for patients' exercises, but these tests are very time-consuming and therapists have limited availabilities. So this is where modern artificial intelligence could come in to perform these tests and offer corrections or generate analysis that help the therapist to make these expert decisions. But the adoption of such monitoring systems still remain a challenge due to the lack of user-centered designs and the opaqueness of machine learning algorithms. So to address the issue, we built on top of our mentor's prior works on a virtual coach that's designed for the therapist directly. We're building a virtual coach for patients with musculoskeletal and neurological diseases such as strokes that, one, identifies the compensations and two, provide feedback and corrections. So here's our final system overview. We have our user, the patient who's seated in a chair, and we use a Connect sensor to capture the videos and then join coordinates. And then this data is being passed to our hybrid model, which consists the deep neural network model, the k-nearest neighbor model, and then the rule-based model. Then the model makes predictions and generates corrections based on the predictions that shows to the therapist directly. In our system, the therapist still comes in, but the therapist only annotates the training data and then elicits the rules. The reason we need a therapist to elicit the rules is because you can imagine the rules for someone who just started therapy is going to be completely different for someone who already started therapy for 6 months. So in our proof of concept, patients are instructed to raise their wrist to their mouth as if they're drinking water. This is an exercise for elbow flexion. So the hybrid model identifies and corrects the following 3 compensations. So 1 is tilted head, 2 is the elevated shoulders, and 3rd is the lean trunk. As for our user interface, like we said, both the therapist and the patients can use it directly. So we have 2 different views. One for the patients, where the patients can see the compensation directly and also see the feedback that the model generates. And then for the therapist view, the therapist can review the patient's behaviors, progress, and also elicit the rules and label the new training data. So in our model comparisons section, we evaluated the models with 3 metrics. So first is performance. We had training data for 15 patients in total and then 10 trials per patient. So we applied leave 1 trial out cross-validation for each patient, and then we compared their F1 scores. The second metric we have is explainability. We want to see how the predictions can help generate the corrections. And then our third metric is new patient friendly. So by that we mean whether the patient can receive helpful feedback without the intervention of therapists. So with our naive rule-based model, it has great explainability and it's new patient friendly because there's default values, but the performance is not as good. For k-nearest neighbor model, the performance is there, but it doesn't offer explainability, nor is it new patient friendly because we need training data for patients with both compensation frames and non-compensation frames. For the deep neural network model, because we're using a universal deep neural network that fits for all the patients, it's new patient friendly and it also has a really good performance. Then finally moving to our hybrid model that combines all 3 of the 3 models above. So performance-wise, we evaluated the F1 scores for all 15 patients we have, and we only look at the here we only have a visualization for the spine composition for space purpose. But we can see that our hybrid model has comparative performance as neural network when neural network has good performance. And it even has better performance than the neural network when neural network has low performance, such as patient number 11 and patient number 12. And our hybrid model has explainability that the rule-based model offers, and is new patient-friendly because we have models that doesn't require any annotations nor training. So for our future work, we hope to include more rehab exercises. Right now, we only have this one exercise where it's like drinking the water. In one of our mentors' prior work, there were 3 exercises that were performed that are generally commonly used in like therapist or clinical trials. So integrating more exercises would be beneficial. We also want to get more therapist insights on the corrections that we're generating. Of course, like we're not nowhere near as professional as the therapists are. And thirdly, we weren't able to conduct any user study tests with like patients because of just the long process of getting access. And then the next one is we hope to explore more corrections or like modalities of feedback. So right now we only have textual feedback. We hope to explore more of in the haptics, in the auditory, and also in the tactile forms. And finally, right now we still rely on a Connect sensor, which is not very accessible to most patients if they want to use that at home. So what would be helpful is to use computer vision to eliminate the need of the sensor and then make the system more accessible. Like it would be nice if someone can just do it on their smartphone. Our main takeaway from the project is that in order to facilitate human AI interactions for AI systems that supplement either experts' decision on decision making or correct non-experts' behavior, it's very important and valuable to analyze the task itself to construct a hybrid model that has a both good performance and clear explainability. The reason we say this is that when we first started this project, our hybrid model was only deep neural networks and rule-based. We thought it would, we thought it already covers the good performance and explainability, but what we realized is that the nature of the exercises that the patients are performing and then the features that we're selecting, KN models is actually offers better accuracy in some certain cases. That's it, and here are our reference. Thank you.
Okay, so our software are combined by 2 parts. The first part is the patient UI. We are Catherine pretends to be the patient and have a stroke, and here we start the process. In this training, Catherine does not have any compensations, so she did pretty well. And the feedback says that there's no compensation detected. However, in the next one, she will try to pretend that she has some of the compensations. Okay, can see that there are some advices here, and the compensations are labeled with red points. And just like we said, there are also the therapist view. Here is a therapist view, where the therapist can watch the replay of the patients, and all the statistics are over here. So the therapist can see how the patients developed, and he can play either frame by frame or just play in circle, and he can pause anytime, label, manually label, and also change the threshold. So if the therapist thinks that the patient is making some progress, he can lower the threshold, and so the training will be harder for the patients. And yeah, that's basically the demo we have.